start. Okay, so we are going, this is technically 8.5 in the Algebra 2 book. We're moving right along with those guys. And you're going to have problems that look like this. Some of them are very easy, like this one will be. When you're adding fractions, you need a common denominator. Your two denominators have to be the same before you add your fractions. This one, they happen to be the same. So since they are, our common denominator goes on the bottom. You just keep whatever the denominator is, and you add your tops. That'll get you a 10. That is the answer to the problem. Common denominator. They will get harder, but not yet. So here's another one. Remember, when you're adding fractions, the denominators need to be the same. So if you had something like this one, again, because it's addition, you're going to look and go, I need a common denominator. And you look. Uh-oh, what did I do wrong, Liam? What's wrong? What do you think? Yeah, I miswrote that. Darn it all. Sorry, everybody. Evil teacher. Okay, there we go. So now we have our denominators are the same. So now, what can we do to the top of this, Kaylee? Right, which is what? It sure is. And your denominator is going to be what, Chelsea? Correct. But remember, when you're adding fractions, the denominator, that common denominator, is your denominator that you use. Awesome. So if you can't add those together, we'll do one you can't. So let's say this over x minus 2 plus 5. This one's answer is going to look a little different than the other two, but you're still looking for the same thing. There's a common denominator. See how the denominators are the same? So this is not a hard problem yet. But the tops this time are not going to add like the other two did. Amanda, what's going to be on the top of this? What's your numerator? You add those. Very good. It's 3 plus 5x. Or you could put 5x plus 3. Either way is fine. And what's going to be your denominator, Hunter? Correct. So just because there's a plus sign doesn't mean you actually will always add them. It just means that you need to write it down as an addition problem. Here we had like terms, so that added. Here we had like terms, so it added. Here there were not like terms. Pause. Keep going. Okay, so for this one, what's going to happen this time is I'm going to warn you they're not going to be like each other. So with that said, 3. You notice this time they are not the same. Like the denominators are not the same. Now, how you handle that, Logan, sit up. How you're going to handle that is you're going to go, what is this one missing? Oh my gosh, it doesn't have an x plus 1. So you're going to come over here, and you're going to put, I'll grab another color, you're going to put an x plus 1 down here on the bottom. Now, obviously, you can't just start sticking numbers on other numbers and think there's no consequence to that. If I put an x plus 1 under here, I'm going to have to go up here and put an x plus 1. Now, don't blurt this out because I want to give somebody, okay, move into the proof stuff. Okay, so Hannah, what are we going to get up top? When you're adding the common denominators, they're not the same. What can you do to this difference of squares, though? Nick, what can you do? All right, we're going to go x plus 5. We're going to factor it, x minus 5. So this will be gone. Now, when you compare the two denominators, Corey, what's the only difference? If this one needs an x plus 5, correct? So if I go ahead and put an x plus 5 over here, where else am I going to need to put it, Corey? On top, so I'll put my x plus 5. But now what's happened is if you look at the denominators, and I'm going to grab a highlighter here, we take the time to look at our denominators actually match now. Remember, that's what we have to do before you add. You've got to get your denominators matching. Chelsea? This one had an x plus 5 and an x minus 5 already. This one was missing the x plus 5, so we only had to put the x plus 5 on there. No, you do not, because this was already part of this problem. We did not impose it on the problem, so it didn't have to be done. Okay, so I am now going to write down what my denominator is on the bottom, the x plus 5 and our x minus 5. Okay. And then up top, what are we going to do with the 3x in this, Palmer? Yeah, we got to distribute. Did you know what to get? Excellent. Well done. That is correct. And then don't forget about, we have this plus 2 sitting here. This plus 2 needs to be stuck on here, plus 2. So that is your answer. And there's no DCF, so that's the end of that problem. Keep going.